Hello everybody, this is Aaron Schwartz with the secondary math team from Montgomery County Public Schools. In this screencast, we're going to talk about assessment Clang. We'll define assessment Clang, identify some of the types of assessment Clang, viewed an example of assessment Clang, and discuss Clang rooted in interdependent items. Assessment Clang has a very clear definition. In assessment, Clang is anything that causes a misrepresentation of student knowledge. In large-scale assessments, like the SAT and ACT, item statistics are carefully measured for potential Clang. So when we have Clang, we're really talking about that misrepresentation of student knowledge. For example, if students have deep content knowledge, but items are constructed so that it's impossible for them to demonstrate that knowledge, they'll do poorly and their data will underrepresent what they know. Whereas if items are constructed poorly so that a student with no content knowledge can correctly guess the answers, that assessment will overrepresent what students know. Let's go back to that SAT and that ACT and other large-scale assessments and think about one way they view assessment Clang. To explore some Clang, consider an item that appears early in half of test forms and late in the other half of test forms. If students who see the item later are more likely to be incorrect, the item might be a better indication of fatigue than content knowledge. Student knowledge is underrepresented in this case. If students who see the item later show vastly greater success, an earlier portion of the test may give clues to the correct answer. In this case, the item measures how closely a student read the test, not the student's content mastery. In this second case, student knowledge is actually vastly overrepresented. Cultural or geographic concerns. If student groups avoid an item, the context of the item might be outside their frame of reference, or even if the content is not. Such items measure student backgrounds, not content mastery. An example of this would be if we asked a question on crab populations to students in rural Nebraska versus students who live along the Chesapeake Bay. Even if the content knowledge measured is not about crabs but about population growth, students in rural Nebraska may be more likely to avoid the item. That means that the item represents a geographic bias. Students don't approach the item because it's outside their frame of reference. Now let's take a look at some examples of MCPS assessments that have had Clang. These are past assessments, and these items have been modified or removed since the last time they were given. What is the Clang in these items? Item number 4. What are the coordinates of the vertex, and what does the vertex tell you about the bird's flight? Which of the following forms of the quadratic function would be most efficient for answering number 4? Circle 1. Standard form, vertex form, or factored form. You've probably noticed that the word vertex appears twice in number 4 and is one of the answers in number 5. This means that you can actually answer number 5 without knowing the content. And because of those context clues, a student with no knowledge of the topic can correctly guess the answer to number 5. This assessment Clang means that number 5 will overrepresent what students know. In fact, a good indicator of this is whether students can even answer number 4 and whether or not they answer number 5 correctly. There's a good chance that if students cannot answer number 4, but they answer number 5 correctly, you've got a good case for assessment Clang. Now, that's not saying that they should be penalized necessarily. The real learning is that it means we have to revise our assessment to better avoid this type of Clang. Now, there's also the Clang formed by interdependence. This is also from a past MCPS assessment which has been removed and upgraded. The situation is assessed using a number of interdependent stems. Students must classify the function type, explain their rationale, graph, and write an equation. Interdependence is problematic to grade. For example, how do you grade if the student has the wrong function type, but their equation matches the type chosen? They answered the item incorrectly, but their work is consistent all the way through. Should they be given full credit for everything? Should they be marked wrong for everything? Let's take a look at another example. What if a student correctly graphs the points, but their table was incorrect? How do you grade it then? Do you grade them on incorrectly representing the points from the table? Or do you penalize the points in the table but give them credit for the graph? What do you do in this scenario? While most of us would favor giving the points in the graph or giving the points in the table, but one but not both, the reality is that this causes a vast misrepresentation of what students know. In fact, it's not exactly clear what students know because they got part of it right and part of it wrong, and their answers are incongruent. Let's think about the third bullet. What if a student whose equation is correct, but their graph or function type is not? Again, what do you do? They have shown some understanding, but are we sure that that understanding really reflects what students know? We have a case where we have discrepant information and it's not clear. This leads to one very important conclusion. Interdependent items should be avoided as much as possible. All efforts should be made to keep items discrete. This is not always going to be possible, but it's advice that should be followed as often as we can. Because when you have these discrepant pieces of information on an interdependent item, it becomes difficult to know what students actually know. When they got one part right and one part wrong and they do not match, which is the better representation of student knowledge? We just don't know with the limited items that we may have on that particular assessment. And so again, interdependent items should be avoided as much as possible. In summary, assessment Clang misrepresents what our students demonstrate about the topic we are assessing. It can overstate or understate what students demonstrate about the content. Assessment Clang can occur within items and from item to item. Excessive use of interdependent items compounds the misrepresentation of student understanding. I hope this video clarified what assessment Clang is and where it may crop up in assessments. There are other forms of assessment Clang, and if you have questions, please email me, and I'll be happy to answer any questions that you have.